Acid-base reactions. These are also called neutralization reactions. So we have to talk briefly about what acids and bases are. We've talked about acids a little bit. Acids tend to form hydrogen ions in solution. We recognize them as acids because their formulas begin with hydrogen and their names contain the word acid. Acids have a sour taste. The reason that Sour Patch Kids are so sour is because there's acid on the outside of the candy. Now, it's not acid as in the drug acid. It's like, I think it's ascorbic acid or citric acid, tartaric acid, something like that. It's an organic acid. It's not toxic, but it's just sour. Personally, I don't like that, but my kids do. Another thing about acids is they can dissolve some metals. And then bases tend to form hydroxide ions when we put them in solution. And so the ones we're going to learn to recognize are metal hydroxides, things like sodium hydroxide, calcium hydroxide. If you see OH in the formula for an ionic compound, that's going to be the base. Bases taste bitter. We don't like bitter tastes, and so there are very few bases that we consume as food, which is good because bases don't get along with tissue very well. It tends to dissolve it, and so you don't want to be eating bitter things because it's going to be really toxic. And they tend to feel slippery. So here are some common acids and bases, and hopefully we find these names at least familiar. So here's hydrochloric and hydrobromic acid. Those are two binary acids. We've got nitric, sulfuric, perchloric, and acetic acid. And over here are some of the metal hydroxides: sodium, lithium, potassium, calcium, and barium hydroxide. These are common bases. And if you look at their formulas, we see this OH. That's what you're looking for to identify this as the base. And all of these formulas start with H. So an acid-base reaction is a reaction between an acid and a base, and they neutralize each other. And we can think of these in the same way that we thought of those precipitation reactions. We'll learn there's another way of classifying these reactions. It's called a double displacement reaction, which means that you have two pairs that are swapping partners. So we've got the same idea with people going to a party here. Here we've got hydrochloric acid. Hydrochloric acid forms hydrogen ions and chloride ions when you put it in solution. And sodium hydroxide forms sodium ions and hydroxide ions. And they go to the party, and then we see what happens when they switch partners. Well, we're going to put the hydrogen ion with the hydroxide ion and the sodium with the chloride. And this is +1, -1. Push them together, we've got sodium chloride, salt. It's soluble. H plus and OH minus, if you stick those together, you've got +1, -1, you might get HOH, and hopefully that looks a little strange. How about putting the two H's together? That's water, right? So just swapping partners, and we can predict the products of this acid-base reaction. So what happens is you're going to get water because the acids all have hydrogen ion and the bases have hydroxide ion. So you're always going to get this. And then you're going to get the other ions, the cation from the base and the anion from the acid, and that's going to make an ionic compound. Salt is the general term for an ionic compound.